So, Sarah, we normally think of life, or at least I do, as the dominion of biologists or at times chemists, but rarely of physicists. So, I just wanted to start off by asking, and how was it that your physics training ended up merging with biology?
It's a great question. I think it's interesting to me because wanting to be a scientist, I was not really thinking about disciplines. I just got really excited about physics and the sort of mindset of the physicist, which is, in my mind, like the enterprise of theoretical physics is to come up with the deepest, most abstract explanations for reality. And it doesn't really matter what parts of reality you're trying to describe. It's just the process of doing it in that kind of way, like finding very deep mathematical regularities to describe these things that we think are universal patterns in nature. And when I started studying physics, I was particularly interested in the idea that the human mind could come up with new theories and test them. So I remember very vividly being in my physics class at a community college. So, like first year physics, it was, like very informal. And being really romanticized by this idea that we could predict the existence of magnetic monopoles. So, like, they're, an interesting physical object. It's, a magnetic pole has a north and south. If you cut it in half, it still has a north and south. So, some physicists had proposed this idea that you might have an isolated north or south pole, and this could be an interesting physical object in the universe if we could find it, because it would prove some new ideas about physics. And I thought it was kind of insane, actually, and amazing and beautiful that people could be sitting here on Earth thinking these thoughts about what could be possible in the universe and then build technology to go and find it. And so that was actually that connection between our ability to comprehend nature and then actually go out and discover new things was really why I wanted to become a physicist. And so then I thought, the places people ask that are like in cosmology and particle physics and things like that. So I just was on a track to do that. And it was when I was a PhD student and I got introduced to the problem of the origin of life that I started working on biology. And that's kind of an interesting transition. I think people think it's not, like a not expected transition. Like, why would somebody wanting to study fundamental theoretical physics suddenly decide to work on this problem in biology? It's actually really funny because there would be like very prominent biologists telling me I shouldn't work on origins of life. I should work on something easier in biology if I wanted to work on a biological problem. And then you'd be able to solve the origin of life. And I always thought it was the other way around because I thought, well, the origin of life is so hard unless you confront that problem head on. No one's going to solve it and needs new ideas. And that was part of the reason that I got really interested in it was just because of this idea that there was something we don't understand. So the origin of life, as I understood it as a PhD student when I started reading the literature, was a problem that people from chemistry and biology and a little bit of physics had tried to tackle. But nobody really had an idea of how to ask the right question. So there were a lot of prebiotic chemists, which are people trained primarily in organic chemistry, trying to synthesize the molecules of life, mostly the simplest ones, because they want to do it under supposedly prebiotic conditions, so conditions that could have been present on early Earth, and make molecules that are building blocks of life. So that was sort of like the dominant area of research in origins of life. And then there were some people that were in molecular biology or genetics trying to think about like what the simplest genetic systems were, how we could trace back from modern life to the earliest life forms. And this was really perplexing to me reading the literature because I thought, well, there's a huge gap here between very simple molecules and a cellular architecture. And no one's really asking questions about the transition from non-life to life. And so this question of like what discipline is adequate for that is actually, I think it's not any of the current disciplines because most of the disciplines that we have now, including biology, emerged to address certain patterns and regularities. So biology is itself a fairly new science, only probably about as old as the early 1800s, really developed in the age of the development of evolutionary theory with like Lamarck and Darwin, and then, into the 1900s with molecular biology, where people were trying to really understand the patterns in the living world. And physics, emerged, you know, a bit earlier, a century or two earlier, trying to understand some of the regularities in the physical world, the non living world. And chemistry was in this kind of weird space in between. And so maybe chemistry has the most to offer the origin of life because we think that life emerges in chemistry, but the traditional questions that chemists ask are very different than this question of non life to life. And so I guess what I really saw was there's not really a home for this question. And if there were a home for this question, it probably would emerge an entirely new discipline because it would be studying some other problem that we actually don't know how to answer yet. Which in my mind is something at the intersection of information and materiality in nature. And like, how is it that the universe generates novelty and produces complexity? Um, and and so I guess the short answer to your question is these disciplines are human derived categories. And what physics does as a particular discipline to me is just looks at patterns in nature and tries to understand the deepest regularities. And I don't see any reason why we can't do that for life. And in particular, I am, I don't really market myself as a biologist. I am an astrobiologist, which is somebody that studies life generally in the universe. We don't have other examples, but the astrobiological lens on the biology problem is really to think about universalities. And so this is where I think it becomes a natural home to be somebody that's trained in the way that I am to try to look for deep regularities to actually ask questions in this space.